Welcome, JEE Preparation channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is voltage and current in DC circuits, the essential Kirchhoff's laws based problem solving skill for circuit networks. Let's begin. Kirchhoff's current law, KCL, states that the total current entering any circuit junction must exactly equal the total current leaving that same junction. This is a direct, necessary consequence of genuine charge conservation. Charge simply cannot accumulate or vanish at an ordinary junction point. Kirchhoff's voltage law, KVL, states that the sum of all voltage changes around any genuinely closed loop in a circuit must equal exactly zero. This is a direct consequence of energy conservation. Since electric potential is a well-defined, single-valued function or position, returning to your exact starting point must genuinely bring you back to the exact same potential. Applying KVL practically requires a consistent sign convention. Moving through a resistor in the same direction as assumed current flow gives a voltage drop, negative, while moving through a battery from its negative to positive terminal gives the voltage rise, positive, and consistently tracking these signs around the complete loop is exactly where most student errors genuinely occur. Resistors in series share the exact same current, and their voltages add, giving an equivalent resistance equal to the simple sum, R1 plus R2 plus R3, and so on. Resistors in parallel share the exact same voltage across each one and their currents add, giving an equivalent resistance found from the reciprocal formula, 1 over R equivalent equals 1 over R1, plus 1 over R2, plus 1 over R3. A genuinely useful punctually applied special case. For exactly two resistors in parallel, this simplifies directly to R1 times R2, all divided by R1 plus R2, the specific product over some shortcut, worth having immediately available than working through full reciprocal formula every single time. Cells in series add their EMFs directly, while cells in parallel, assuming genuinely identical EMFs, keep the same overall EMF, but reduce the effective internal resistance, since the individual internal resistances themselves now combine in parallel. For any DC circuit problem, first simplify the circuit as much as genuinely possible, combining obvious series and parallel resistor groups before applying Kirchhoff's laws to whatever more complex network genuinely remains. When a circuit cannot be simplified through simple series parallel reduction alone, typically because of a genuinely more complex bridge-like network, assign an unknown current variable to each distinct branch, apply KCL at enough junctions, and KVL around enough independent loops to generate exactly enough simultaneous equations to solve for every single unknown current. A frequently tested trap involves a Wheatstone bridge specifically balanced where no current flows through the bridge's own central galvanometer arm. Recognizing this specific balanced condition immediately, the ratio of resistors into adjacent arms equals the ratio in the other two lets you skip the entire simultaneous equations approach completely and solve directly, far faster. Let's recap. Kirchhoff's current law reflects charge conservation at junctions, while Kirchhoff's voltage law reflects energy conservation around closed loops, both essential for solving circuits that can't be simplified through basic series parallel reduction. Series resistors share current and add resistance directly, while parallel resistors share voltage and add as reciprocals, with a handy product over some shortcut for exactly two resistors, and recognizing a balanced Wheatstone bridge lets you skip the full simultaneous equations approach entirely. And current Pachu Philadelphia Philad, SIPHONYNOU SIPMANDRIMON FORIGA, FONYMONYZONYS and double sign conventions sharp. They're the foundation for every circuit problem in this chapter. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.